You're welcome to another episode of Let's Solve Mathematics. In this episode, we'll be looking at how we can solve simultaneous equation using matrix form. Now, we have a question on the board here. Let's solve this question using matrix. Now, the matrix form of this simultaneous equation is 2, 1, 1, 2. Now, the matrix form is built based on the coefficient of each of the x and y. So the coefficient of x here is 2, that of y here is 1, that of x here is 1, and that of y here is 2. Then you put your xy this way and equate it to the result. So 3 and 9 is the result. So this is the matrix form of this simultaneous equation. Now, we will get the determinant of this number, and the determinant is gotten by multiplying this and subtract the result of this and this. And taking the inverse of that determinant, it will be 1 all over 2 times 2 minus 1 times 1 times 2, that's the matrix, 1, 2, this way, and then x, y, equal to 3, 9. Now, we'll multiply each side, the left hand side and the right hand side, by the inverse form of this matrix. So 1 all over 2 times 2 is 4 minus 1 gives us 3. So 3 times the inverse form of this is 2 minus 1, 2. Now the result here, the number here and here is the same. That is why we cannot see the difference here. But taking the negative form of this number and this number shows the inverse form of that number. So we multiply it by this, which is 2. Okay, let's do it this way. We have 2, 1, 1, 2 times x, y equal to 3, 9 multiplied by this inverse form, which is 2 minus 1 and 2 times the inverse of the determinant. Now, every time you multiply a number by its inverse form, your result becomes 0. And with that, the format used here is 1, 0, 0, 1. This is the result of multiplying this by its inverse. And then we have x over y equal to, now I'll multiply this 3 by 1 over 3, that will give me 1, and then 3 times 1 over 3 will give me 3. So I have 3 times 2 minus 1, 2, and this will give me x, y will now result to 1 times 2 will give me 2 plus 3 times minus 1 will give me minus 3. And then 1 times minus 1 again will give me minus 1. 3 times 2 gives me 6. X, y will result to 2 minus 3 gives me minus 1, minus 1 plus 6 is 5. So x here is equal to minus 1 and y is equal to 5. That's the result of the simultaneous equation. X here is minus 1 and y is 5. Let's look at the second question. The second question, the coefficient is 7 and 4, 4 and 2. And then we have our x, y equal to 29, 16. Now, the determinant of this is 7 times 2 minus 4 times 4. And the inverse form is 1 all over that. That's 7 times 2 minus 4 times 4 equal to, multiplied by 7, 4, 4, 2 times x, y equal to 29, 16. Now this one is 7 times 2 is 14 minus 16, that's minus 2. So we have 1 over minus 1 over 2. Now the inverse form of this is 2, 4, 4, 7. This becomes minus. That is, we change this row to column and this row to column as well. So the 7 comes down and then 2 goes up. So this is the inverse form of this number, and then multiplied by itself, 7, 4, 4, 2. X, y equal to 29, 16. 29, 16. Then the inverse determinant is 1 minus 1 over 2 times the inverse form of this number, which is of our matrix, 2 minus 4 minus 4 and 7. Now, the multiplication of this by its inverse will give us 1, 0, 0, 1, and x, y. Now, minus 2 multiplied to the 2 we cancel 2, so we have minus 1 from this, and then the same minus half times this will give us the minus, will cancel the minus, and then we'll have 2 here, and then this times is 2, 2, we'll also have 2 here, this, we'll have minus 7 times 1 over 2 this way. Now, this will give us xy equal to 29 times minus 1 will give us minus 29, and then 16 times 2 will give us 32, and then 29 times 2 again will give us 2 times 9 is 18, take 1, 2 times 2, 4 plus 1, 5, plus 16 times this, 2 here, 1, 2 here is 8, 8 times 7 will give us 56 minus 56. So here we have 29 minus 29 plus 32 will give us 3, and 58 minus 56 will give us 2. So this means our x is 3 equal to 3 and our y is equal to 2. Thank you. Thank you for watching. Thank you for being there. See you in the next episode.